Welcome to Beginning Ham Radio. We are sponsored by the Portland Amateur Radio Club. And for August 26, 2021, we're going to talk about Yagi antennas. So I'm just going to use Google Images for looking at pictures of the radiation pattern. This particular radiation pattern is a dipole in free space. So it's the theoretical dipole. And essentially, it just looks like a donut where you have a lot of radiation coming off the sides. And this is looking at the antenna is the Z-axis here, I guess what they labeled Z, but you could consider it Y. And so there is a deep null in the center of it. But in general, it's just kind of like a donut expanding through space. It will radiate equally in all directions. And that's why a vertical dipole like this is really considered a omnidirectional antenna. And that can be great for some things. If you're into emergency communications and you are talking to a lot of people in a lot of different directions, you don't want your antenna rejecting signals from certain directions from you. So this is a great antenna, general use antenna. There's certainly nothing wrong with it, but a lot of people, especially when they are working HF, remote or DX, or they're using VHF and UHF, but they really just want to focus their signal in one direction, then they'll actually pull out the Yagi antenna. Let me just pull up basic picture of that. So Yagi antennas are used for many things. Anything from your old TV type antennas, where you'll see here in this picture on the right hand side, this is essentially a dipole, and it's where the coax is attached to. So that's going to be called your driven element because it's the one that the RF energy is applied. But the rest of the elements here are actually not attached to the coax in any way. So they're just kind of hanging out there in free space. And the ones behind are called reflectors, and they are the ones that kind of help direct the signal or the RF energy away from them. And they also help reject the RF energy if there is any behind them. So it helps basically, just like it says, reflect the signal away from it and help kind of push it in the opposite direction. Anything in front of a driven element is called a director. And these are usually shorter. And what they do is they kind of help direct the RF energy in that direction. There is no law or rule that says that you have to have a reflector or a director. Obviously, if you don't have any, that's not a Yagi antenna, but there are antennas that just have a reflector, and there are antennas that just have a director. More commonly, if you're just going to have one or the other, you would actually have a reflector. So when you look at the Yagi antenna pattern, here's just an example of one I pulled up, and this is really looking at the antenna from the top, kind of bird's eye view down. And you can see that unlike the donut that we saw before, the Yagi antenna is really able to squeeze and push a lot of the energy in one direction. You'll still have some in the opposite direction, but kind of an insignificant amount. And off to the sides, you'll typically have also a lot of rejection. So a Yagi antenna is not really a good antenna if you're looking for something where you don't know where the signal is coming from. However, if you have a good idea of where the signal is coming from or where you want to, for example, call CQ, then a Yagi antenna is a great antenna. A couple of examples of Yagi antennas that I just wanted to show you. We built one for the club, and we use it for field day. And it's what's called a 40-meter beam wire antenna. This was from QST, and it was June 2018. QST is great because that's the radio, or the magazine that's published every month by the American Radio Relay League. And so they'll oftentimes, in almost every issue, they'll have some type of project like this that you can build. This one didn't have a lot of, I think it's only 2 pages, but it gave us enough information on how to build it that we actually were able to build it. It took, I would say, probably 5 hours, and we were working really slow. And so if I zoom in here to the bottom, here's the diagram of what the antenna looks like. And this is this looks like you're looking from either the top down or the bottom up. So it's not a cross-section view. But you'll see here that this is your driven element. You'll have a center insulator. So one side of the antenna is on the right side and the other side is on the left side. And then the only other thing it has is a reflector. And this is 70 feet of wire that's just hanging out in free space, and it's not connected to anything. The ends are actually connected to 2 dog bone insulators. And this works really well. You can use this very easily on 40. It covers the entire band, both the CW and digital on the lower section of the band and the voice on the upper section. Let's see if they have it. They don't have any other pictures, but they do give a list of materials. And one of the things that they list is an 18-foot long aluminum, wood, or fiberglass poles. And those are at the ends, and they kind of just keep the antenna spread out. The harness here, all the other lines here that you see in black are made out of rope, and you just essentially hang it from a catenary line. So if you have 2 trees and you put a line, like a rope, between them, you can just attach this antenna one side to one end of the rope and the other side to the other, and it's self-leveling. So if there's a wind that picks up, it'll actually just kind of right itself. And it works really well. It's not short. So because it's 40 meters, you can see that the backside is 70 feet of copper wire. And it does, hang down just a little bit, depending on how much tension you have on your rope, but it's good enough that it works very well as a reflector. So typically when you think of Yagi antennas, you're thinking of shorter antennas, nothing more than 20 feet, because they're made out of aluminum or some other really stiff material that doesn't droop too much, because you don't want too much droop. Some of it is acceptable. So Yagi antennas, yes, they're, for the most part, they're used a lot at the VHF, UHF section, just because they are so inexpensive and easy to build. And I'm going to share my browser again. And one example of that is Aero Antenna. And these are portable satellite antennas. And they do, so Aero Antenna, they make a lot of different antennas, and the most popular one is going to be, yep, this one. So this is 2 Yagi antennas, and they are separated 90 degrees from each other. And it's a 3-element antenna on 2 meters and a 7-element antenna on 440. This particular antenna is very popular with people who do satellite work. So you can actually stand out in the middle of the field or in your front yard and use this antenna to talk through a satellite as if it were a repeater. And a lot of satellites, the way that they operate is that they have an uplink frequency and then they have a downlink frequency. And there's a lot of satellites that use like 2 meters for the uplink and 440 for the downlink, or vice versa. And that's what this antenna does really well is you can use the same boom that you're holding to hold two different Yagi antennas. And the great thing is, because they're separated by 90 degrees, you don't have to worry about interference from one to another. Now, yes, it is possible to build the antenna, both Yagi antennas, in the same plane, but you have to tune them and make sure that they aren't interfering with each other. So if anybody's interested in amateur radio satellite work, this is one of the more popular antennas. It does come with two different connectors. So you'll have in the lower right-hand corner here, this is a gamma match is what they call it. And really you connect your coax to it. And then if required, you can adjust this bar up and down. It's kind of like a shorting bar to get the best SWR. Now, when I bought mine, they're pre-tuned. So once you take them out of the box, usually you don't have any issues with them. If you drop them or if you really take them all apart, you may have to then use an antenna analyzer to adjust the gamma match again. They're not cheap. They run, it looks like about $90 to $150, $160, depending on what types of accessories that you have. One of the things that this one offers is for $160, you get a duplexer. And a duplexer essentially takes these two outputs, one here and one here, from the coax, and it combines them together. So if you have a dual band radio, you can connect your one coax to two different antennas at the same time. And the duplexer kind of just separates out the signals, not only in transmitting, but then in receiving also. The one thing with that duplexers you do need to be cognizant of is you can't necessarily put 100 watts through this particular duplexer. It's rated for 10 watts, and that's in the 10 WBP model number for that duplexer. There's nothing that says that you can't take this antenna on top of a mountain and use it as a directional antenna for summits on the air or just making contacts with other people. Summits on the air is becoming so popular now that in any given weekend, as long as there's not like really bad weather, you can take a handheld radio up onto the top of a mountain and call CQ on a calling frequency, like the 2 meter 146.52. And there's enough people listening that you'll probably talk to quite a few people. Summits on the air, they also have spotting networks. So with your cell phone and an app, you can actually just spot yourself, which essentially is a way for you to tell everybody who's looking at the spotting network that, hey, I'm on this mountain at this time at this frequency. So they can very easily just turn on the radio and hear you calling CQ and make a contact. So you don't necessarily need a Yagi antenna. However, it does help because if you're using something like a handheld radio at 5 watts, a Yagi antenna, by concentrating the energy in one direction and rejecting it from another, it's essentially like increasing your power without actually increasing your power. Because the more directional your signal is, the less energy it's going to take to make the same type of contact. So I actually did take an antenna that was similar to this up to Mary's Peak. And we made a contact from Mary's Peak down towards another peak. And I apologize, I don't remember the name of the peak that the other person was on. And it was over 150 miles away. And they too were using just a handheld radio and a Yagi antenna. So the one that I used, the Yagi antenna, was a homemade tape measure Yagi antenna. And this is something that is very easy to make. And if you have like a spare tape measure or a tape measure that you never really liked in the first place, this is something that is kind of fun to do. Let's see if I can blow up these pictures a little bit. So here's, all you have to do is just Google tape measure Yagi. Here is a video with complete directions, parts list, and measurements for exactly how to build this. And I think actually this is the exact website that I use to build my Yagi antenna and the tape measure Yagi antenna. And you'll see that they have a gamma match down here that was similar to what we saw before. And it's just a piece of copper wire that you can use from Romex or some other, usually you want to use a solid piece. It's just easier to form. Besides the tape measure, PVC pipe makes really good booms, and plumbers clamps will work really well on the outside. So you just clamp those. The director and the reflector, they're just one long piece of tape measure. And so you just clamp those on, you don't connect them to anything. And then the other piece, the driven element, you do have to cut in half. And I don't know if he has a picture down below. In the video, he probably does, where you cut it in half, and that's where you attach both sides of the coax. So one side of the coax, the shield, gets soldered to one side, and then the center element gets soldered to the other. I think when I built mine, I put it on an antenna analyzer, and I don't think I actually had to make any adjustments. If you follow the directions, they give you like 35 1/8 inch here for the director and 41 3/8 inch for the reflector. If you follow them, you pretty much are spot on. In fact, this is this looks like where he attached the coax. And so what he did was, once he got it so that the SWR was okay, he just put some hot glue on top of it. And that kind of just seals that coax from, if you're going to use it outside for extended period of time. I'll stop here for any questions.
I do have a question.
Yeah.
So with the different types of antennas, I'm learning that they're all tuned differently. And so for this tape measure Yagi, are all, oh no, so I know now not all the Yagis are similar, because that one for the satellites is a dual, one's horizontal, one's vertical. So in a later club meeting, or maybe you'll get to it later, how does one tune this type of antenna? If I have an analyzer, I got one, because I got one of those high gain Yagi antennas off of the interwebs and have no idea what to do with it. So I'm sure you're getting there.
Yeah, so it really depends on the antenna. I think with this antenna, the way that you tune it is, if you got the hairpin match pretty exact with your measurements, and they do give the measurements down here. So it looks like 1 1/8 inch between the hairpins match, and then the whole other dimension is then 2 3/16. So if you got that pretty spot on, then you're good. The way that you would adjust the SWR is you would loosen the clamps here on either side, and you would either bring them in just a little bit or pull them out just a little bit. And because we're talking VHF frequencies, just a little bit means maybe like a few centimeters, and then try it again, and then try it another few centimeters. When I built this antenna, I really don't remember having to do that more than once or twice. Realize that when you say tune this antenna, the first thing you kind of want to do is just, this is your dipole antenna right here. And so to tune that dipole, you want to either make the elements longer or shorter. And the best way to do that is just make them a little bit further out or a little bit further in, given that you are pretty good at cutting the actual length of the element.
So if I understand this correctly, the way when you said this is your dipole right here, so each of these yellow and red segments on this Yagi descriptor on the screen, each one of those is itself a dipole, and you'll do the SDR for each, lengthening
No,
or shortening?
yeah, so only the center one is the
Oh,
driven element, and that's the one that the coax is connected to. The other
ah,
ones are really just the shorter one is a director, and the longer one is a reflector. The SWR is going to be affected somewhat by the length of the director and the reflector. It's really going to be, you're going to affect the pattern more than you will the SWR. So for those, you just kind of want to make sure that the measurements are correct for the dipole that you're building. But the dipole is in the center, and that's what you want to adjust in order to get a good match for your SWR.
I really appreciate you taking the time to explain
Yeah,
it over and over. That really
yeah,
helps.
no
Thank you very much.
problem. Yeah, and it can be frustrating, especially if you like it sounds like you inherited an antenna. It may or may not have come with directions. Fortunately, today a lot of antennas, even the old ones, right, the ones that are out of production, the manuals are available online, and so they will kind of help guide you on tuning the antenna. It can get a little frustrating, especially if the antenna is all apart when you get it and you have to put it together, because sometimes, especially when things start to corrode or they don't tighten as well as they should, that's when you may have to finesse it a little bit. Fortunately, RF energy, you don't necessarily need a really good electrical connection. So if there is a little bit of corrosion, it's not great, but it'll still work as an antenna, if that makes sense.
Yeah, you absolutely answered a few of the questions that I had before I even asked them. It's
Nice.
one of those, it came in a box and it kind of has a diagram of what it should look like when it's together, but the rest is like, good luck.
Yeah.
I'm looking forward to the learning process. As frustrating as it is, the satisfaction of learning this is just, you're wonderful.
Oh, thank you very much. Thanks. Yeah, in when we talk about antennas, there's really two ways to erect or get an antenna on the air, right? You can either buy it, whether it's new or used, or you can build it. And in the past, when ham radios were first starting out in the 1920s, 1930s, there weren't companies that made antennas. But now that there's a ton of companies that make antennas. Sometimes the easiest way to get on the air is just to buy one. However, once you buy a couple, you'll realize that there's not a lot to these antennas, especially wire antennas. Wire is fairly inexpensive. If you're looking to do either dipoles or Yagi type antennas, if we go on to DX Engineering, for example, and take a look at their wire for antennas. I bought let's see if we can find it, a roll of antenna wire. It's the thicker kind of wire. I think this is it. And I bought a 1,000-foot roll. Yep. So it looks like it did go up in price since I last bought it, but a 1,000-foot roll of really good, high quality antenna wire that you can leave outside for many, many years, $180. That will make you a lot of antennas. Now they do have, cheaper, like 500 feet is, looks like about $100. And this particular wire here is pretty, I think it's 14 gauge stranded. It is insulated, so when you're making antennas and it's insulated, you may need to shorten it just a little bit to get a good SWR. But 14 gauge stranded antenna is pretty heavy duty wire. If you're looking for something that maybe isn't a couple hundred feet long, you can get away with a much thinner wire. So even 26 gauge wire will easily handle 100, 250 watts. depending on what type of other components are in it, but the wire itself is actually really good. So when you compare even 75 feet of wire for $15, right? 75 feet of wire will actually make you a very nice 40, maybe even an 80-meter antenna. But if you take a look at dipole antenna, so here is a Buckmaster OCF, which is off-center fed dipole antenna. So this is a multi-band antenna, but it comes with 2 insulators for the ends. This wire here is probably pretty much the same wire that I showed before, and a center insulator. There's nothing magic about this center insulator. It's essentially, I think it probably has a place to put a hook if you wanted to use it as an inverted V. If you're using it as just a regular dipole, then you can just string it between 2 trees. But do you see the price of this antenna? So, but yet it's nothing really more than wire, a couple of insulators that can be had for less than a couple dollars, and a center insulator that you could technically buy if you wanted to, or make. I oftentimes just have extra pieces of plastic that I drill some holes into and make an antenna out of that as a center insulator. So yes, you can buy an antenna. And this is true for all types of antennas. Yagi antennas are no exception. There are some, the one exception I would say is that there's some Yagi antennas that are much more advanced. They have motors in them, they're multi-band, they're designed to go on a tower. And once you start looking at tower things, tower antennas, a lot of people just end up buying them. You can still make them. And the one example that I'll show you is called the stepper IR. So this is a company that makes both amateur and commercial, mainly for military. But if you go to their amateur site, I was actually able to build one of their antennas. It's a horizontal Yagi antenna, and it was a 3-element. And it was this one right here. It's called the DB18. And this antenna is for 40 to 6 meters. And this replaced an antenna that was on the top of an 8th-floor building in Milwaukee that is a retirement home. And they had one of these antennas up there for, I think, probably 15, almost 20 years. And the weather kind of got to it. They don't last forever, but it is a Yagi antenna. And there we go. So the way that this works is this, these are our motor housing units, and they will, they have elements in them that you can push out and pull back in. And the material that they use is very similar to tape measure type metal. It's made out of a different material that lasts a lot longer. But can you guys still hear me?
I can, yeah.
I can too.
Okay. Sorry, I'm using the same, cool. So these motor housing units push in and pull out a tape measure type material, and each one of these can be a driven element, or it can be a reflector, or it can be a director. So for example, for 20 meters, this controller will attach the coax to this particular element, and it will adjust the SW bar by pushing in and pulling out the tape that's inside. And then on the back here, it will actually push out another tape that is the reflector. And then the front unit here, it will push out a tape to use as the director. So the director is going to be the smallest. The driven element is going to be kind of the mid-size one, and then the end one here, the reflector is going to be a larger a tape. So the nice thing about this antenna is that if you wanted to rotate the antenna all the way around 180 degrees and you wanted to shift your signal from going from one direction to the opposite direction, it doesn't actually need to turn the boom at all. All it does is it shortens or it lengthens this one and shortens this one. And it's like a smart Yagi antenna. Now it does come at a price. I don't know if you guys saw the price, but for just the antenna package plus, I think the controller, it's $41.42. So it's kind of one of those antennas that you want to make sure that you're really interested in ham radio before you go out and buy it. It comes as a kit. It took me about 30 hours to assemble this antenna very carefully, and that was on the ground before you actually put it up in the air. But it's one of those antennas, the Yagi antennas, that's has a lot of bells and whistles to it, and it makes it really easy to make contacts because it basically does everything for you as far as where it points it, changing bands, and things like that. So the reason that there's a loop here in the front and the back is because remember a dipole antenna does not necessarily need to be completely straight. You can actually loop a dipole antenna back on itself to make it longer, but still maintain the same length. That is definitely something that when you get into the upper bands, for example, 40 meters, 80 meters, 160 meters, a lot of people do is they won't necessarily have the dipole go in the same direction. So I'll stop here for any questions. The other thing I was going to point out is that there are different types of Yagi antennas. They don't necessarily just need to be straight beams that go out. Here's an example of a 20 meter, this particular one, they call it a 20 meter Yagi in the attic. And here's your driven element right here, sort of in the center. And you can see that there's a ball in here and at the feed point. And then they have just shorter and longer wires that they've attached to the rafter. Now, you don't necessarily have to attach them to the rafter. You can easily attach them. Let me see if I can find a bigger example of one. And this is called a delta loop, just simply because it looks like the delta sign. And they don't necessarily have to go as a right side up triangle. They can go as an upside down triangle, depending on how you hang them up in the air. So a lot of people that have trees, you can use an upside down triangle. Your feed point then is at the lower end of one of the triangles. But if you have just a mast or a pole, you can use a right side up triangle. And so you can just use a single pole for each of these elements to hang it up in the air. So any questions on this so far? There is also four-sided antennas that also act as a Yagi. Usually they're called like box antennas. I'm trying to think of the other name because that's not it. But essentially, they are antennas that are in the shape of a box instead of the shape of a triangle. And those are very easy to build at VHF and UHF frequencies because the size are really only a few inches on each side. Let me take a look for those. Any questions so far? If you're going to build a Yagi antenna out of like aluminum or copper, most of the Yagi antennas that are bigger, for example, 10 to 20 feet in length for the elements, usually people will use aluminum because it's lightweight and it's very weather resistant. And it's also pretty rigid, so you're not going to get a lot of droop. It's not necessarily easy to just run down to Home Depot or Lowe's to buy aluminum tubing. So most people, when they do buy aluminum tubing, they'll go to a special metal shop or they will buy it online. And depending on where you get it, it can be, you know, somewhat expensive or not very expensive. Aluminum is going to, you know, cost you some money if you are going to build one for, let's say, 20 meters. But it's certainly going to be a lot less expensive than if you were to just buy a kit for 20 meters. The other place that you could do, or what you could do, is you could just look online or contact your local amateur radio club, and you can find out if somebody has one that they're giving away. Because if you're in ham radio as a hobby for any amount of time, you will quickly find that you start accumulating things, and other people do the same thing, and they will either give to you or sell you for an extremely low cost all sorts of antennas and radios and things like that.
May I add one thing to what you're just saying?
Cool. So I'm going to just open it up to any questions in general on ham radio, unless anybody has antenna specific questions. And if you guys are interested in making a tape measure Yagi antenna, this particular antenna that is detailed on this page, and I'll put this in the chat, is a dual band antenna. And so you can see that he has 3 elements for the 2 meters, and I think 5 elements for the 440. And again, he has offset those by 90 degrees. And that way you don't have to worry about trying to tune both bands that are using the same plane because they're not going to get interference between the two of them. Let me just pull up the chat and paste that in here. The other one that we saw was the Aero Antenna. This is a great site to just go take a look at because they do have a lot of Yagi antennas, but they also have these Dipole antennas, and they're fairly inexpensive. If you're looking for an outdoor antenna, here's an example of what they call an open stub Dipole. So it's for 2 meters and 440. And they may make other bands too. Yeah, so they do. They actually have business band, marine, and MURS, which is the 150 megahertz. And they may even have, do they have GMRS? I don't see it. Oh, there it is, the GMRS. So this is a dual band. MURS is it's a radio frequency that's licensed by rule, which means that you don't necessarily need to take a test. All you really need to do is, for MURS or MERS, you actually just buy the radio and start using it. It's 2 watts only, whereas GMRS, technically, yes, you're supposed to get a license for it. It's, I think, $70 now for 10 years. And that's in the 462, 467 megahertz range. So that's why it's a dual band, whereas MERS is in the 152 megahertz range. So take a look at this website. I'll just paste that into chat also. Cool. How's everybody else doing ham radio wise? one of the things I'll do is I'll put up a list of the upcoming topics that we have. So next week is going to be antenna feed lines, coax and ladder line. If you're all interested in HF radio, this would be a really good one, because ladder line is it's a feed line that was really popular in the before coax came along. Coax is wonderful stuff. It allows you to run your antenna feed line from outside, inside gutters, next to gutters, right through the walls that may have metal in them. You can even put them through a window that has metal casing on it, and it really doesn't affect it at all. Whereas ladder line is really different, but you can't bury ladder line. You can't. You really want to keep it away from metal objects, at least by a couple inches. But the wonderful thing about ladder line is that it allows you to use antennas that are cut for different bands on other bands. So the 40-meter wire beam antenna that I showed earlier, we actually use that on 20 meters, 80 meters, 15 meters using ladder line. We could not do that using coax. The other wonderful thing about ladder line is that you can, it's very low loss. So you can run easily 500 feet, 1,000 feet of ladder line and get almost as much energy out of the end of it as you can with running. I'm sorry, almost as much energy out of the end as what you actually put into the other end. Whereas coax, especially at higher frequencies such as VHF and UHF, you start losing a lot of energy the more coax that you are running through it. And if you're starting with QRP, that means that you're not going to have a lot of energy left at your antenna. We'll also talk about ham radio go bags and kits. So if you guys are interested in putting some type of go bag or go box together with VHF or HF or both types of radios in them, that'll be a great one. I built a few in my day. The one thing I will say is that when I first started building them, they were pretty complicated, and I learned very quickly the best thing for a go bag or a go kit is to make it as simple as possible. It's a lot cheaper and a lot less things can go wrong with it. Following week, we'll talk about digital modes like FT8 and PSK31. We'll have ham radio equipment reviews. So if you're interested in buying ham radio, but aren't sure what to buy, we'll talk about that. And then finally, power poles, which are connectors for power that a lot of ham radio people use. Cool. Any questions or comments?
Are Yagis, this is Stevie Ray and 7AOE. Are Yagis affected by masts in the same way that wire antennas are? Because I'm at that point now where I'm like trying to figure
out.
And
I'm going to stop sharing for just a second.
Oh, sorry, go ahead.
Give me just a second. Okay, I'm just trying. There we go. Okay, sorry, I may not have been able to hear you guys. All right, so I'm back. So any questions at this point or future topics that you'd like to see?
Am I coming in, Max, at all?
Yes, now I can hear you.
Oh, wonderful. Last question. In
Yeah.
regards to the Yagi antennas, and I'm wanting to understand the putting them together and getting them analyzed to be resonant and then tuning. How does the mast affect? Because I'm in my understanding of the topic so far, there's metal masts and then there's fiberglass masts. And like say K6ARK, for an example, he uses fiberglass masts, but he uses a wire antennas like an end-fed half wave. So my question is like very specific to my use case, but I think other people might run into this question is, can I put like that dipole barber pole that we made? Can I put that up on a metal mast? Can I put a Yagi on it? Because they're oriented differently. Yeah. So I don't know if that's for now or for a later topic, but those are the questions that are coming up for me now.
Yeah, absolutely. Yeah, and that's a great question. So one thing to keep in mind is that different antennas are going to have different radiation patterns. So for a dipole antenna, you essentially have, if it's done horizontally, right, you will have one on either side going horizontally. For a vertical antenna, it'll be this way. The big thing to keep in mind with any antenna is that you don't want to have metal objects within the radiation pattern where there's a lot of RF energy. Now, fortunately for the barber pole antenna, which is a vertical, essentially it's a vertical antenna, right? It is wound, but it's a vertical dipole. If you were to mount that on top of a metal mast, it really doesn't affect it at all, because where the metal mast lies is within the null. It's within the donut hole, so it's not really going to affect it at all. Even horizontal dipoles, it won't affect it at all. Now, you don't want to get you want to make sure that where you put the metal mast is sort of either in the center where where the coax essentially connects to each side of the dipole. Now, there are off-center dipoles where the feed line or feed point is not in the middle. You could still put your metal mast there and it won't affect it at all. Obviously, you don't want to put it anywhere else along the line except for at the end. But if you do put it at the end, give it a good foot or more of non-conductive rope and fasten it with a insulator.
You're brilliant. Brilliant.
Cool, thanks. Yeah, there really is not a lot of there aren't a lot of antennas that are affected by mounting them to a metal mast or a metal tower. In fact, most people, especially the Yagi antennas, because they are heavy, they need more than just a wire, more than just rope to suspend. If you want to take a look at some crazy antennas, let me just pull up an image. With Yagis, you can stack Yagi antennas. There are some, rules to how far they need to be separated and what bands they are. But a lot of hams, when they put up a tower, they'll put up multiple antennas onto the same tower, multiple Yagi antennas. Here's a good example where you have two very large Yagi antennas, but they are stacked so that they operate independently from each other. Here's another one that's stacked. So this looks like well, it doesn't really say, it's a 5-element 2-meter Yagi antenna. They have to maintain a certain vertical distance so that they don't interfere with each other. But because they're horizontally polarized, they actually work really well. The other thing to keep in mind is that any type of ground plane antenna, this could be a mag mount antenna, or let's take a look at like one that you would mount on the side of your house would be a diamond. So you've probably seen these type of antennas. You can make them very easily just using a connector and some copper wire. A lot of people, they will bend the ground planes down. The ground plane is the other side of the antenna. It's what the signal pushes off of. So typically the braided portion or the outer shield of the coax will get connected to like little spikes, essentially, that are either bent down or in this case here, they are just straight out. So that gets connected to one side of the antenna, and then the other side of the antenna gets connected to the vertical section. These types of antennas, because it's a ground plane, it doesn't even care what you put below it. You probably don't want to put a lot of RF energy below it, but if you have gutters or if you have other metal pieces, the antenna typically or realistically does not see any of that. So that's kind of one good thing to keep in mind is if you're attaching this to your roof, if you just get it a few inches above your gutter line, that's actually perfectly acceptable. Good question, Stevie. Any other questions or comments?
I was going to say, does a HLP antenna fall into the type of Yagi by chance, or is that a totally different animal?
You said HOV?
HLP, horizontal log periodic.
Oh, yeah. Yeah, so that's a great question. So let's talk just for a couple minutes about that. So log periodic antennas, everybody's probably seen these. They are antennas that have like an obscene number of elements on them. And typically they'll have a few reflectors, but a lot of directors. So here is an example of one that is used for cellular. Here's one that's used for VHF and UHF. So this one is from DX Engineering. Let's see what kind. So it'll do 500 watts. It's a 50 ohm antenna, which means that you can use it very easily by connecting it to coax. It is 105 to 1300 megahertz.
Are you sharing, Max?
What's that?
Are you sharing?
Oh, I'm sorry. Yeah, that's a good idea. All right, can you see that?
Yep.
Okay, so yeah, so here's an antenna example of a log periodic. The great thing about log periodics is that they're fairly wide band. So this particular one is 105 to 1300 megahertz. I don't know if this is necessarily a transmitting antenna. Log periodics typically are great receiving antennas, and they're very wide band, which is why people like them a lot. But they don't necessarily make for great transmitting antennas.
Yeah, the reason I asked, when I was in the service in the 70s, that's what we used for transmitting and receiving for 2 to 30 megahertz. So they were huge antennas. They were portable.
Yeah, so there are quite a few. And this one, obviously, yes, you can transmit on it because it's rated for 500 watts.
Yeah, ours, we were transmitting 1500 or 15K.
Yeah.
CW. So
now, did you have
interesting antenna to set up? Pardon?
Oh, I was just going to ask, when you transmitted on it, did you have to tune the antenna every time you changed bands significantly?
Yeah, our equipment actually auto-tuned. It had a coil with a roller in the power amplifier that automatically tuned to the frequency.
Yeah, and because it's such a wide band antenna, you would need to retune if you went too far up or down the band from where you were transmitting last. It's not necessarily a really efficient antenna because you do need to tune it. So a lot of any any antenna that is cut for a specific frequency or specific band is going to be a lot better than a multi-band antenna that you then have to use some other type of matching device like a tuner in order to get the SWR low enough to either transmit or effectively receive on. Log periodics are an example of a great antenna that it's a sort of like a multi-band antenna, but at the same time, it's not as good of an antenna as one that you would cut for a very specific band.
Right. And the other thing I was going to ask is on the tape measure, Yagi, could you actually use individual tape measures for each and tie them together, then keep it adjustable where you can retune it to different bands?
That's a good question. You could, because there's nothing wrong with basically rolling up any portion of the antenna that you don't want to use, because when it sees when RF gets transmitted out, it's going to see that roll as just a shortened antenna. A lot of people, when they do build the tape measure Yagis, though, they'll either build them for 1 or 2 bands and just separate them by the 90 degrees, or they'll just build multiple antennas just because they're so cheap.
Right.
But that's actually the concept of the stepper IR, is that they put the tape measures in the middle and they use motors to push and pull the antenna. So you could do that. You just have to find a good way to attach the RF electrically to the driven element.
Right. That's an interesting thought there.
Yeah.
that I have.
I have seen people, they won't necessarily use a tape measure for the driven element, but they will use it for the ground. So if you're going to use like a wire antenna, you could like put the wire antenna out so far and then use a tape measure on the ground to kind of as your counterpoise. And it is better to get a counterpoise that is the correct size. Counterpoises aren't typically, you don't need to have them. They're not as fussy. Like if it's too long or too short, it's not going to be a big deal unless it's like really too short. But there are people I've seen that have used tape measures for that.
Okay. I have to give that a try.
Yeah. Cool. Any other questions, comments? The last slide I have is just if you have any questions, comments, or want other topics. I'm going to start making some new topics in a couple of weeks because we're running out. I think I have until end of September, but just email me. My email's on the screen, max@nultra.com. And then don't forget, we have our meeting coming up September 13th.